I take this top-down approach. Now here we will learn few things like client-server paradigm. We keep on saying that so-called Google server and all. We will get to know today that why I keep on saying so-called Google server. Service models, TCP, UDP, reliable, unreliable service model. We will learn that, but more specifically in the transport layer. We will learn the protocols, HTTP, FTP, SMTP, POP, DNS. But believe me, all of you have used it already. You have browsed web, that means you have used HTTP. You have used email, you send email, you receive email, that means you have used SMTP, POP. If you are browsing web, basically you are taking help from DNS. We will get to understand these things. Then we will look into something known as socket as well. Now, what is this application layer doing? Application layer is responsible for communicating among the distributed processes, right? Running in network hosts in user space, exchange messages to implement application. These nomenclatures we can keep on repeating, but at the one liner of the story is this is where we users have something to do, some role to play. Now I look at computer network as a teamwork. Teamwork in the sense all the layers, they must work correctly. Then only even your single bit of data gets delivered from sender to receiver. All layers, it must work in tandem. Now, if that is so, I hope you realize that every layer has to take help from its upper layer and lower layer. It has to take help because they must work in tandem. Application layer being the topmost layer, there is no upper layer to it. So it takes help from transport layer to deliver data to the lower layer, that is network layer. It has to take help. It cannot work on its own. I cannot say, oh, my application layer work is working fine. That's why the data is getting delivered. Transport and network layer ঠিকমতো কাজ করছে না। ওরকম হয় না ব্যাপারটা। It does not work that way. Okay. So all of them, they must work correctly. Then only it gets delivered. So last point, use communication services provided by lower layer protocols, either TCP or UDP. TCP for reliable transmission, UDP for unreliable transmission. We'll understand that, don't worry. Now, this is basically the application to application layer logical communication. Physical communication, how it happens, we saw in last class. This is interesting. From your OS knowledge, you know that process is nothing but a program in execution is process. Fine. We talked about this example a few minutes back, which is like, say, if you have Office installed in your machine, that means msword.exe, that particular file is residing, that particular program file is residing in your hard disk. So it's a program. From a layman's perspective, as soon as you double click on that word icon, your msword.exe, that program now becomes a process. I hope we agree on this point because it starts using your CPU time. So within the same host, two processes communicate using inter-process communication. You know it. Your operating system takes care of that. It defines the rules that how to go ahead with that, IPC. But we are more, in fact, I am more interested when processes are running in different hosts. Communicate with an application layer protocol. Just to give you an insight, we have subsequent slides to discuss this. When you are requesting from your Chrome browser, you are requesting the Google homepage, right? Basically, you are asking for a copy of the Google homepage to be delivered at your machine and to get displayed on your screen through the Chrome browser. Now, your machine, I hope you realize there are n number of processes running. Say you have kept open your Internet Explorer, your Mozilla Firefox, and your Chrome also. 3 browsers. Same type of processes, 3 are browsers. It's a layman's understanding that if I request the Google homepage from Chrome, the reply will come back in the Chrome browser only. The reply will not come back in Mozilla Firefox or your Internet Explorer. Is not it so? So there must be some way. We will learn what is that way. there must be some way by virtue of which a data getting transmitted from California understands that there is a small machine somewhere in Newtown, Kolkata, in West Bengal, India, Asia, where I have to deliver this data, that too in the Chrome browser and not in the Notepad or Microsoft PowerPoint or not in Firefox or Internet Explorer. It comes back to your Chrome and Chrome only from where you had requested. There must be something, some magic must be there so that this complex process happens without any error. Now, what is this user agent? Forget about the nomenclature, you have already used it. If you have browsed web, so basically you have used the agent browser. If you have checked your email through browser or through Outlook Express or Microsoft Outlook, you have already used the agent mail reader. Streaming audio video, all of you, in fact, you use this more than browsing web these days. Media player, there are online media players as well. Now, this is interesting. First and foremost, client server two nomenclatures. That's why I prefer physical classes. Nevertheless, let me ask you here. What do you think? Client. Let us take the nomenclature client first. Is it a software or a hardware? Your answers please in the question panel. Client, is it a software or a hardware? Your answers. There are people who have started answering. I should have created a poll also. Anyway, your answers are welcome. There are, okay, it's like 50% of the people are saying software, 50% of the people, almost 50%, they are saying it's a hardware. Okay, let me check whether I am getting the answer or not. The correct answer or not. All the answers are correct, but we need some clarifications on this. Yeah. So how many softwares? Yeah, okay, yeah. Almost 50% I got software and almost 50% I got hardware. One person has played it safe. He has said hardware and software both. Another person has tried to play it a bit more in a bureaucratic manner. It may be software or hardware according to the network. Oh my God. Okay. Another person says both. Let's play safe. Both. Okay, there are persons who are giving example to access any service. We use client, for example, Gmail. Okay, so let us understand what it is. Is it a software or a hardware? Requesting process. Requesting process is the client process. Okay. So when your machine, from your machine, you opened up Chrome browser and you requested your so-called Google server, still I'm saying so-called, you requested so-called Google server for a copy of the home page to be delivered at your machine, to be displayed on your terminal. So which is the requesting process? Chrome browser, chrome.exe is the requesting process. Okay. So let us try to put it in a parlance. Requesting process is the client process. There are a few points written. I am coming to that. Then is it only a software? It's not a hardware. Now understand it clearly. The machine in which the requesting process or the client process resides is known as the client machine. Understand it carefully. Requesting process is the client process, and the machine in which the requesting process, the client process resides, that is known as client machine. Some of you had said it's both in this way. Understood? So requesting process is the client process, and the machine in which it resides is the client machine. Then what is server? Is it a software or a hardware? The answer goes in the same line. The responding process is the server process. Responding process is the server process, and the machine in which it resides is your server machine. Now understand this clearly. The Chrome process is residing in your machine. Your machine is the client machine. Where is it going? It is going to a machine somewhere, maybe in California. We are not having any mirror server in India, for example. It is directly going to California. In that machine, there must be a web server or an application server running it. Okay? Which is your so-called Google server. That dabba is your Google server, but there must be an application running, a software process running, application server process running. This request goes to that application server process in that machine, and that process responds. So Chrome process is the client process, requesting process in your machine, and your machine is the client machine. The Google application server process is the responding process, and the machine in which that process is running is your server machine. Now, if some engineer opens the browser process in your so-called Google server, that particular machine, and requests for the service, what happens? That same machine is working as requesting process machine as well as responding process machine. Let us take an even easier example. In your machine, you have installed Tomcat server, web server. Through JSP, you have created an application, JSP server. You have created an application. Now, from the browser of your machine, you are trying to access the home page of that application which you have created, which is being executed by the Tomcat server. So which is the client machine here? Requesting process is the browser in this machine. So client machine is this one. Responding process is the Tomcat web server running in this machine. So Tomcat web server is the responding process running in which machine? This machine only. So this is the server machine. So your client machine and server machine can be same as well, depending on the situation. So basically, client process is the requesting process. The machine in which it runs is the client machine. The responding process is the server process. The machine in which it runs is the server machine. As simple as that. Let us look into the points. Client initiates contact with the server, speaks first. I hope you understand that if it is speaking first, the server must be running to listen to that request. It's not instant. If the server is off and the client requests, there is no point in requesting because the responding process is not alive, it's not listening. So server process must be running first. Client initiates the contact, speaks first. Typically requests service from server. Web client implemented in browser, email in mail reader, we will understand these things separately in protocols. Server provides requested service to the client. That so-called Google server, I hope now you have understood that what is that server means. Provides requested service to client. Web server sends requested web page, copy of it. Mail server delivers email, so on and so forth. Let me look into some of the answers. Yeah, so it was truncated there itself. Great. So this is what it is. Request goes, response comes. That's your client server paradigm. As simple as that. Now API, application programming interface. We will talk about socket in the later part of this layer. Don't worry. This query on the right hand side, this particular query is interesting. How does a process identify the other process to which it wants to communicate? Means from my machine, Chrome process, you are sending the request to the application server in your so-called Google server machine. How does it get to know? Because that machine is running several processes. Out of those several processes, which process must get my message? How will I get to know? I means my machine. Let me explain it with an example. Say, I reside in a multi-story building. Fine. When you are writing me a letter, you will be writing the area to which it must get delivered, then the apartment name, the whole thing, the multi-story building name, the address of that multi-story building, then I'll just be back. Give me a second. Yeah, sorry for the interruption. So now say you are writing me a letter and so you will be writing the apartment name, the address of the building. Then, for example, there are 3 Shukallan Goswamis residing in the same building. Possible, right? So how do you differentiate between them? You want to send the letter to me. So basically you will be writing flat 3B, the flat in which I reside in that building. You will be giving that particular address, that Shukallan Goswami residing in flat 3B. Other 3 can be other Shukallans, but you are not interested about them. So you are identifying me with a particular number of the flat in which I am residing. Now, if that happens in a human-to-human interaction, I hope you realize that same thing will be happening in a scenario, network scenario which humans have created, right? So you are saying that when I am trying to deliver the message to the so-called Google server and application server process of that, I need to identify that process. So what happens in the background? That machine's IP address will tell me means the requesting process machine. That machine's IP address will tell me where to which machine the data will be delivered. Fine. Next, in that machine, there are so many processes running. How will that particular process be identified? That is known by port number. We are introducing another number known as port number. This is network port, okay? Network port number, which is basically the process. It is different from process ID because you are learning operating system in the same semester. This is completely different from your PID, okay? We will get to understand some of the examples. We will start. You will figure out that and this port number they are different. So that port will identify software port, network software port. Yes, this is the port, this is the process to which I need to communicate. So we'll explain it with an example, don't worry. But human psychology says, you are the receiver of the letter. You are the receiver of the letter, I am the sender. So what is mandatory? I must know your address. Please understand it carefully. You are the receiver of the letter, I am the sender of the letter. Then what is mandatory? I must know your address. And then what do? in my letter, I will be giving my address also, so that once you receive the letter, you can respond back to me. In my letter, I am writing the address to which you must reply back, my address. In my letter, I am writing it, sending it to you. So you have now access to my address, you can reply back. Clear enough? Great. Next, if this is human process, then that remains same. I'll come back to this. Let us directly jump to the HTTP protocol, the protocol of web. I'll come back to those 3 slides, don't worry. All of you have used it. You are browsing web, that means you have used it. So first and foremost, it works on client server model. Means unless there is a request coming from the client, HTTP request, there will be no response. So it's pull model over internet. The HTTP request goes, HTTP response comes. HTTP request goes, HTTP response comes. Right? Unless there is a request, there will be no response. So it's a pull model over internet. Browser or your email reader, we are talking HTTP protocol only. Browser will be the requesting process. Web server or application server will be the responding process. As simple as that. There are a few things written here. RFC 1945, that was for HTTP 1.0. HTTP 1.1, next version, the RFC was 2068. What is this RFC? RFC stands for Request for Comment. Request for Comment. It's a document. Say 1945 RFC is basically the specification of HTTP 1.0. Why it is known as RFC, Request for Comment? It's an open document. Anyone can have a look at it, understand it, and anyone can suggest some improvement changes. Now, is it like I suggest improvement change and the HTTP 1.0 gets changed? Not actually. For every RFC, there is a specific expert group who are responsible. Any request for change or updation comes in, they will look into, they will analyze, their implementation will happen, and so many things happen before it gets part of that RFC, updated RFC. So it's not that easy that I send some comment and it directly gets implemented. Not that. Okay. This is how it works. I mean, very, very interesting, because you have used it till this time. Now you get to understand that how does it work. I told you, when I am sending you a letter, I must know your address. Similarly, when my browser is sending a request to so-called Google server, that to application server process of that machine, it must know few things. What are those? It must know where that machine is located exactly. তার পাশে আরেকটা মেশিন রাখা আছে, সেটাই যেন পৌঁছে না যায়. It must locate that machine, and in that machine it must locate the correct process also, because there are n number of processes running in that machine. I must locate the correct process also. There are n number of Shukla and Goswami residing in an apartment. You must locate the one who is residing in 3B. Then only your job is done. Now, so client initiates TCP connection. Okay. For the time being, let us understand that TCP is responsible for reliable data delivery. So why do I need reliable data delivery for web? You know it better than me. If you are asking for a home page of Google, you will like the full home page to come, right? Otherwise, you get a Google home page without the search bar. Will you like that to happen? Not actually. So you want the whole home page to be displayed on your terminal. So web requires, or HTTP as a protocol requires reliable data transmission. Or when you are searching, it must give you all the data given by so-called Google server displayed on your terminal. So it requires 100% reliable data delivery. That's why TCP. Client initiates TCP connection, creates socket. We will understand what socket is. It's a logical pipe. Don't worry. We will understand. Client initiates TCP connection to server port 80. There comes the important part. That means my machine, client means my machine. I am initiating the request. What do I need to know? I need to know the IP address of the Google server. Then only it will reach the correct machine. I need to know which process should I communicate to, HTTP server process. So I must know the port number, server software port number of that process as well. So here comes your HTTP server port address known as port 80. Okay. So if it is HTTP, the HTTP server is running at port 80. That is the flag 3B. You knew my address, flag 3B, that is your port 80. I hope it is clear. Sir, where do I get the IP address of Google server, so-called Google server? Where do I get it from? Don't worry. You have a friend helping you with that known as DNS. We will learn that in detail later on. But as of now, you understand it that this socket creates socket. Socket is nothing but IP address and port number taken together is your socket address. I repeat, IP address and port number taken together is your socket address. So your so-called Google server, if it is residing, its IP address is 1.2.3.4. If the IP address of your Google server is 1.2.3.4 and HTTP server port address you have understood 80, then the socket address to which your client, your machine and your Chrome should transfer data, that socket address is 1.2.3.4 80. 80 is the port address of the server. 1.2.3.4 is the IP address. Both of them taken together is your socket address. In one liner, that is the socket. Once that request went, server accepts TCP connection from client. Fine. Then HTTP messages will get exchanged. So first part is TCP connection request. Then is TCP connection reply. Now the communication is set, connection is set. Then I request for the copy of the home page. That request goes in, the reply comes, the copy of the home page displayed on my terminal. Once that happens, the connection is closed. Connection is closed. As simple as that. Let me look into one of the queries. Yeah, so there are, you know what? This software is a good one. I mean, it shows that what the student is doing as an attendee, whether the audio connection has been kept off or whether it is like the student is offline or online, whether the audio is kept alive or not. It's like someone had answered, it may be software or hardware according to the network. That gentleman, behind his, after his name, within parentheses, it is clearly written that he has left the meeting. Okay. Then that same gentleman had answered masking. In one of the queries, maybe he thought that masking is the answer. And again, after his name, it is kept as he has left the meeting. So basically, as soon as you leave the meeting, in all the comments and queries, whatever you have done, it shows within parentheses that you have left the meeting. So this is a nice software. So it's like people just jump in to ask a question, show that they are present in the class and they leave the meeting. This software can take care of that, can catch hold of it. Anyway, There is one guy who is asking, can you repeat the part of socket address, please? And okay, I'll do that again. Socket is nothing but it's a logical pipe, as simple as that. So it's logical pipe. It's created both the ends, at both the ends. I have not explained socket thoroughly. So from your client end, it's a write socket. You are sending the data, you are writing into the socket. And what is the socket address? Is the IP address and the port number taken together. So when you are sending the data to the so-called Google server, if the IP address of the server is 1.2.3.4, then socket address will be 1.2.3.4.80. That's your socket address. IP address and port number taken together is your socket address. Write socket from your end. At the Google server end, I hope you realize it will be read socket. It has to read the request from the, read the message from the socket. Fine. Then it makes the response. It will send the response back in the socket. Now it is write permission from that end. Here at your end, it will be read by your application layer process, your browser process. So it is read option. So socket must be read and write at both the ends if you are working on client server paradigm. Fine. So let me repeat. HTTP protocol, it works this way. The TCP connection request goes to the particular IP address and port number. IP address is supplied by DNS. Port number for HTTP is 80, server port. Fine. That is the TCP connection request created. The server process responds back. Connection is created now. Then the HTTP request message goes. Give me a copy of the home page. The response comes. Please take this. Then the TCP connection is closed. Done. As simple process just like this. Next, right hand side, there is a statement written in red. HTTP is stateless. HTTP is stateless. Meaning, it does not maintain history. It does not maintain history. Meaning, whenever there is a request coming from an HTTP client, the server responds back, closes the connection. And it does not remember history. Again, if the same request comes from the same client, what will it do? It will again send the data. As simple as that. Why is it kept stateless? Because it does not require to remember history. What is the general size of a web page? 40 kilobyte, 50 kilobyte. So, for transmission of this little amount of data, 40, 50 kilobyte, if we had implemented the technology such a way that HTTP server will remember all the history, that would have been a burden on the HTTP server. But when we move to file transfer protocol, FTP later on, you will get to see that FTP server is stateful. It remembers history. Why? Because the amount of data you are transmitting is huge in megabytes and gigabytes. So it has to remember history so that it can resume the transmission. But for HTTP, the question of resuming the transmission does not arise. 40, 50 kilobyte only. So if the same client is requesting time and again for the same data, it will transmit the same data time and again. I don't remember history because I don't need to remember history. Very small amount of data is exchanged. Protocols that maintain state are complex. Past history must be maintained. If server or client crashes, their views of state may be inconsistent, must be reconciled, so on and so forth. FTP যখন করব তখন সেটা we will take care of that. But the HTTP client maintains history. Okay, we talked about it already. HTTP as a protocol is stateless. It does not maintain history. There are people who know it a priori. People are asking, sir, what about cookies? Someone had asked, what about HTTPS? We will discuss those. Don't worry. So as of now, what is the meaning of server or client crash? If you have understood the client process, server process, client machine, server machine, then you are replying to yourself. When, if your machine is still running, but your client process, say the Chrome browser has crashed, has shut down, or you have forcefully shut it down, do you think the response will come back to that? No, because the process is already killed it. Or if your machine suddenly goes off, and when the machine is off, the response, will it come to your machine, which is already off? Not actually, right? Same thing applies for your server process as well as server machine. Now, yeah, so this is again the same thing which has been reflected in showing the arrowheads one after the other. HTTP client initiates TCP connection to HTTP server. Then what is that server port address? That is 80. That remains static. I need to know your address to send you the letter. HTTP server waiting for TCP connection at 80. That means my flat must be there, flat 3B. Jodi 3B na thake, then where will you deliver the letter? Where will the postman deliver the letter? It's like 221B Baker Street, the place where Sherlock Holmes supposed to reside. There is no 221B Baker Street, right? So similarly, that address must be there to receive the letter. Then once it gets the request, it accepts the connection, notifies the client, yes, the path is now created, logical path, obviously. HTTP client sends the HTTP request message, HTTP server receives the request message, frames the response, sends it back into the socket, right option. Then HTTP server closes the TCP connection. Fine. HTTP client received the response. Great. Now, instead of Google, think of the Yahoo homepage. In your Yahoo homepage, I hope you can recall, there were so many objects, pictures, forget about objects. There are so many pictures embedded in the Yahoo homepage. Is not it so? Great. So please keep this in mind. Next class, we will start the discussion from here. HTTP 1.0, HTTP 1.1. Non-persistent and persistent HTTP. Then we will move to something known as cookies and all those things, conditional get, then cookies, what is web cache, so on and so forth. We will get to those in next class. So what did we learn today? We learned that application layer is basically responsible for this process-to-process communication. HTTP as a protocol takes help from TCP as the underlying transport layer protocol because it requires reliable data delivery. Next, we learned client-server paradigm. We understood HTTP works on the same model, pull model over internet. Unless there is a request, there is no response. Then we understood the basic HTTP process, just now explained through the slides. We will resume the discussion from here next class, HTTP 1.0, 1.1, then all the things I talked about. And then we will go back. Those 3 slides we did not discuss, that what help application layer protocols require from the transport layer. We will discuss in detail. Then we will go to emailing, FTP, DNS, so on and so forth, other protocols in our application layer, right? So it's 11:20 now. Let us see. Yeah, there are queries coming in. Which one is the client address? Yes, we will talk about it. We will talk about the total port number range, and then we will talk about what is this my socket address, the client socket address, which needs to be sent across so that my response can come in. We will discuss these things in detail. Don't worry. So then let's close the session here. Thank you so much. We had around how many? Around 190 students attending the session. That much. Thank you. Thank you so much. Attend the next session. Bye-bye.